I am Tsunami. I know everyone is scared of me. But if you know how and when I come, probably you will not be scared. I am nature's phenomena. Please understand me this way. The world is enough to cause terror, not just among the citizens, but the entire line of the administration. The tsunami that struck the Indian coast on 26 December 2004, the first of its kind. This was the first tsunami before which people did not know that there was something called tsunami. And it taught us, the entire humanity, a big lesson. The 2004. That was a time when we took a vow that we need to develop public awareness and preparedness for tsunami. Here we need to understand how is a tsunami generated. Most large destructive tsunamis are generated by big earthquakes on the ocean floor. One of the most popular theory explaining earthquakes is the plate tectonic theory. A small number of lithospheric plates cover the entire surface of the earth, the continents and the seafloor. They are constantly moving relative to each other at an extremely slow pace, about 4 inches a year. Earthquakes are mostly generated by the movements along the fault zones of plate boundaries. In common man's parlance, when these moving plates come in contact with each other, wherein one slides below the other, the overriding plates get squeezed. This phenomena can go on for decades and even centuries. Because of this, when the stress exceeds a limit, earthquake occurs. Now the question is, earthquakes keep taking place all the time, since the plates in the earth are moving all the time. The issue is, what is the severity of the earthquake? The magnitude is measured on the Richter scale. Higher magnitude means the earth has shaken violently, and when this happens, more damage is likely to take place. The Sumatra earthquake, which generated the 2004 tsunami, was of 9.3 magnitude on the Richter scale. It generated 3 times more powerful tsunamis than the 9 Richter scale earthquake it was originally thought to be. It is also important to know that all earthquakes do not lead to tsunamis. When this earthquake occurs underneath or near the ocean, and it also leads to vertical displacement of water, then tsunamis happen. It is the earthquake that causes the vertical movement of the seafloor over a large area. As the landmass shifts, the wave becomes broader and it heads across the shore like a huge wall. This is what happened in December 2004 tsunami. Most witnesses recall how they saw a huge wall of water, but before they could react, this water wall had reached them. Another important point is the earthquake happens and water gets displaced and starts moving in the direction where its energy takes it. Another trademark of tsunami is the shoreline areas which witness tsunamis see receding of waters. This also clearly happened in the 2004 tsunamis. People at Marina Beach in Chennai, for instance, thought the sight of receding water was great and stayed on to what nature was to show on the extended beach. Then suddenly came the roar and the huge tsunami wall was seen moving towards them. No one realized it was a tsunami. Those who could run backward managed to save lives, but all those who were slow to react submerged in the deadliest ocean-related disaster. Tsunamis have another peculiar characteristic. They are tall waves and move very fast. Tsunami waves can travel at a speed of a commercial plane, which is 800 kilometers per hour. Tsunamis can move from one side of an ocean to the other in less than a day. Since it is a huge mass of water, it gets unnoticed by the ships at sea. Tsunami cannot be noticed from the air also. So then, what can be done? Here is how the Tsunami Warning Center gains importance. A tsunami early warning system detects potentially dangerous earthquakes and provides immediate early warning to countries which may be hit. Waves attack coast near to the source of an earthquake in minutes. Here, shaking of ground is the only warning, which shows that trouble might be on the way. For people on shores which are distant from a tsunami source, accurate warnings of when the waves might strike are possible because tsunamis travel at a known speed. To create the warnings, seismic activity is monitored regularly, like being done at this Tsunami Warning Center at INCOIS, Hyderabad. This is the only of its kind Tsunami Warning Center in the Indian Ocean. Here, earthquakes and its impact on the sea are constantly monitored. Tide stations have been established on the coast to determine the changes in the sea level and transmit the data via satellite to the warning center. Tide stations have their limitations. The gauges are all located at the shore. Although they can warn of approaching local tsunamis, they cannot predict the development and impact of distant tsunamis. Thus, we have bottom pressure recorders, which have been installed in the Bay of Bengal and the Arabian Sea. Bottom pressure sensors, which rest on the ocean floor, are anchored by weight. This is the only of its kind tsunami warning center in the Indian Ocean region. Equipped with state-of-the-art computational and communication infrastructure to monitor all kinds of necessary information from different strategically involved organizations and countries that can help predict tsunami, the Tsunami Warning Center functions 24/7 all days of the year. As the tsunami wave passes, the sensor detects an increase in pressure caused by the weight of the added volume of water. The bottom pressure sensor transmits the reading via sound waves through the water to the nearby surface buoy, which in turn transmits the data to the satellite. Satellite relays the information to the land receiving station, and then it is sent to the Tsunami Warning Center. Scientists here analyze the data, estimate the earthquake magnitude, and watch for reports from tide stations in the quake area, which tells them whether the tsunami wave has raised the water level of a coast and if there could be a tsunami hazard to other areas. Tsunami height measurements in the past and computer modeling can also help forecast tsunami impact and flooding limits at specific coastal areas. The impact of tsunami is different in different areas. In shallow water, tsunami spread is reduced as the wave height increases rapidly and wave becomes compressed. Its speed also reduces as it approaches the coast. When the tsunami reaches the coast, the distance from the coast is what is called inundation. With so much water on shores, damage has to follow. The first to get damaged are the land structures because strong transmissions, induced currents, lead to erosion of foundation and collapse of the building structures. Thus, the houses and the people who stay in them are bound to be adversely hit. The water does not stay still. Flooding by each wave can last from 10 minutes to 45 minutes, and the dangerous period for successive waves can last for hours. Therefore, one must retreat to the coast only after all clear signal is given by the competent authority. Tsunami warning centers' one big test came during September 2007 when an 8.4 magnitude earthquake hit the Java coast. Displacement of water was recorded and a tsunami was predicted. Tsunami did happen, but the direction was off India. The watch given earlier was withdrawn. For a tsunami warning system to be effective, public awareness campaigns, tsunami school curricula, and emergency response exercises are necessary. INCOIS follows a SOP, Standard Operating Procedure for Dissemination of Information. Here the question is, when should the public or administration be warned? If more than 2-meter water is displaced, those areas will be placed under warning. Warning means evacuation is required. If the displacement is 0.05 to 2 meters, those regions shown by mathematical modeling will be put on alert. Alert means no evacuation needed, but beaches must be avoided because strong currents are expected. And if displacement is less than 0.5, the region will be put under watch. Watch means official machinery and the administration must be cautious and on standby. After all, warnings are of little value if people do not know how to react correctly to them. Here comes the role of administration, and how does it respond to warnings or alerts is important. This reaction includes how quickly the administration responds to the alert and is able to lead the citizens to safety. When calamity strikes, everyone must respond. People will do so most effectively if they have the right information and support structures they need. Thus, it is for the administration to ensure people are safe and there are steady buildings built at a height. All coastal places should have such buildings where people can be taken to safety. People should be kept here till the tsunami danger passes. The empowered administration must have everything from running effective warning systems to maps and routes for public evacuation. The administration must also have an integrated building code system where tsunami dangers are built into the multi-hazard emergency planning system. In fact, the administration needs to involve community groups who have a key role to play in public education, social leadership, and relief efforts before, during, and after a disaster. Authorities are in overall charge of search and rescue operations after the disaster. Relief efforts and recovery efforts are also very important. On its part, INCOIS is sending earthquake information regularly to the Ministry of Earth Sciences and the Ministry of Home Affairs for further dissemination to the public. INCOIS has infrastructure to directly send tsunami information to the public in case of any warning. Overall, for an effective strategy, there are certain basic components. Assessing the tsunami hazard and risk at the local level to identify vulnerable communities. Preparing the population so that they know what action to be taken in case of a tsunami warning. Building a technological framework that warns of an advancing tsunami wave. For effective warning and evacuation, an efficient multi-pronged approach is what should be adopted. At the national level, we already have in place a comprehensive disaster and emergency response policy. Ultimately, it is for the administrator to react fast when a tsunami happens. Public awareness also needs to be carried out in regional languages. It should be in a language which, when blared on loudspeakers, can be understood by everyone. It is also necessary to carry out practice drills which will help people understand how to run to safety when an alert or a warning is announced.